Hi all, this is a quick recap of part 2, carbon and its compound. So part 1 link will be given in the description, just have a look at it. So now we'll be seeing homologous series and more detail about the homologous series which contains a functional group. Now let us know the definition of homologous series. So homologous series is a series of compounds. So we know that there will be a lot of compounds in the list with the same functional group and similar chemical properties in which the successive member, which means the next member, differs by CH2 group, which is called as methylene group, or 14 AMU. What is that 14 AMU? We know the atomic mass of carbon is 12 and there are 2 hydrogens, so 14 AMU. Now, if you see more examples of homologous series, you can be in a better idea to understand the definition of homologous series. So, let us see one example. See, we all know that saturated and unsaturated hydrocarbon. So, saturated hydrocarbon is alkanes, A and E, and it contains a single bond. So the general formula is CnH2n plus 2, where N starts from 1 for alkane. So the first member is methane, second is ethane, C2H6. Now if you check this here, CH4 and CH2, the difference in the carbon is C. 2 minus 1 is 1, so C1, H6 minus 4 is 2. So CH2. So the successive member is after methane, it is ethane. So this differs by CH2 group. If you add one CH2 group to C2H6, you will get the next member. So what will be that C2H6 plus one more CH2? It will be C3H8. So that is propane. If you add one more CH2 to it, it will be C4H10 butane. Next will be pentane. Now let us see the homologous series of alkenes. So we all know that alkenes are the double bonded unsaturated hydrocarbon. The general formula is CnH2n. So the first member starts with 2 carbon atom, which means the N starts with 2 carbon atom. So if you substitute in this formula, it will be C2H4. Now, we all know that the successive member differ by CH2 group. So, to this C2H4, if you add CH2, it will be C3H6. If you add again same CH2, it will be C4H8, C5H10. So, the name will end with ENE as an underlined alkene. So, it's ethene, propene, butene, pentene, and it goes on. Now let us see about alkyne. YNE. We all know that alkyne is a triple bonded unsaturated hydrocarbon. The general formula is CnH2n minus 2, where N starts with 2. So C2H2. Again, we all know that the successive members differ by CH2 group. So it will be C3H4, C4H6 and C5H8, which is ethyne, propyne, butane and pentane. Now if you recall the definition for homologous series, they are the series of members, that is list of compounds in which they have same general formula and the successive member differ by CH2 group, that is 14 AMU. Now let us know more about the characteristics of the homologous series. See, each member in the series differ by one methylene group, that is CH2 groups, hence the molecular mass differs by 14 AMU. All the members in the homologous series contain same elements. We all know that same elements means carbon and hydrogen is the element present in all the alkene and alkyne. So the elements will be same as well as functional group will be same. So now let us see more about the functional group of the homologous series containing the functional group after seeing the characteristics of homologous series. So now let us see the third characteristics. So they are represented by a general formula, and there will be a regular gradation in their physical properties because the molecular mass differs by 14 AMU. Now the chemical properties are similar, and all the members in the homologous series can be prepared by a common method. So these are the 6 characteristics of homologous series. Now let us know more about functional group. Then only we can understand the homologous series which contains a functional group. So what is a functional group? An atom or a group of atoms present in a molecule which determines the characteristics property of the organic compound. So let us know with the example. Now if the functional group is OH, it contains alcohol. Imagine the OH is present in one molecule, means this OH is going to give the property of that compound as alcohol. So this is only determining the characteristics property of that compound. So if the functional group is OH, it is alcohol. If it is CHO, it is aldehyde. If it is COOH, it is carboxylic acid. If it is C double bond O, see here both the sides the carbon should be bonded, it is ketone. Ketone will always be in the center, it will not be in the terminal carbon atom. Whereas OH, CHO and COOH will be in the terminal carbon atom, which means in the end in the carbon chain. So these are a few examples of functional group that is there in the syllabus. Now look into the example, that is homologous series of alcohol. So the first alcohol is methanol, CH3OH. So methane is CH4, one hydrogen is replaced by the functional group OH. Now the next member, if you see here, we know that the successive member differ by CH2 group. So CH3OH, now this becomes CH3, CH2OH. Now this becomes CH3, CH2, and one more CH2 will be added here, OH. This is propanol. Now 4 carbon atom in the carbon chain, 1, 2, 3, 4. So this is butane, and the last E will be replaced by OL if it contains alcohol. So it is butanol, pentanol. Remember to write OL carefully. So this is a quick recap of part 2. Thank you all. And if you wanted to know more about the homologous series and how the naming of alkane, alkene and alkyne, you just have to click on the link in the description box.